In this session, we are going to talk about the chapter of Stoichiometry, and basically any question that has to do with how much is a stoichiometric question. In the heart of stoichiometry, we always have a balanced reaction. And therefore, the first thing you have to master before understanding the materials in this chapter is to be able to balance a chemical reaction equation. Now, for instance, we have a fictional reaction of 2A plus B forming 3C, for instance, in gas phase. The number that we write before the name of the symbol of the molecules or the reactants, we call them the coefficient or stoichiometric coefficient. Now, these coefficients directly tell you the number of the molecules or the atom if it's not a molecule. For instance, in this case, if you have 2 mole A, it will react with exactly 1 mole B, and together they will form 3 moles of C. This is what we call the stoichiometric ratio. Now, notice that the unit that we use here is mole. And therefore, we can also use the unit of number of particles because as we discussed in the previous chapter, 1 mole is basically the same with 6.02 times 10 power to the 23rd number of particles. Now, if you have the reactants or the products in different unit, for instance, mass in gram, or you have for solution, you can have, for instance, in volume, which is in liter, and the molarity in molar, right? Or for gas, normally we have the pressure, we have the temperature, and also we have the volume as well. Of course, the first thing that you need to do is to convert all of these values into the mole. We have discussed about this in the mole concept. So, to sum up, the first thing you need to be able to do to master this chapter is be able to balance a chemical reaction equation. And the second one is that you are able to convert the units like mass, volume, pressure, temperature, depending on the phase of the molecules or the elements that you are working with, you have to be able to convert this into mole back and forth. Okay? Please refer to the video in chapter 2 to be able to convert these parameters into mole. And the mole is the unit that you are going to use for the stoichiometry for any kind of balance reaction like this. The unit you are going to use is the mole. So it's very important for you to be able to do these two things. Balance a reaction and convert mass for solid, volume and molarity for aqueous system, pressure, temperature, and volume for gas system to be able to get the mole. Now, coming back to this reaction, you don't always have 1 mole of A and 2 mole of A starting with. Sometimes you have, for say, both 2 moles, or sometimes you have 2 moles of A and instead 1 mole of B, like this. Okay? Now, what happens if you have the non-stoichiometric ratio starting for your reaction? Now, to be able to solve this, we have to always make this table that we will write down as the following. First, we have the initial condition, symbolized as I. And then we are going to have the change, which is C. And finally, we will have a final state after they react that we are going to, in this case, call the F. So initial, change, and final. Now, in this case, because we don't have the stoichiometric ratio of A and B, we are going to determine first something that we call the limiting reactant. The limiting reactant is the reactant that will be consumed completely during the reaction, meaning that in the final state, you will no longer have this reactant, or the amount of this reactant is going to be 0. Now, we have two different reactants, which are A and B. How do we determine which one between A and B that is the limiting reactant in this composition? To do this, first we take the initial of each of the reactants, so the initial for A and then the initial for B, and we divide this with the coefficient of A and the coefficient of B. Don't forget, we have to take the initial state. So in this case, we're going to have 2, which is the mole of A, divided by 1, which is the coefficient of A over here, it's 1. Then we take 1, which is the mole of B. Don't forget, this is mole divided by the coefficient of B, which is in this case is equal to 2. So you get 2 for A, and then you get 0.5 or a half for B. You compare this value, and then you take the smallest one, in this case B, and therefore B is the limiting reactant.